Welcome everyone. In this session, we are going to discuss another DSA problem which is titled as valid triangle number. So let's try to understand the problem statement. So you will be given an integer array. Let's say it is nums. Suppose it's given as 4, 2, 3, 4. What you are supposed to do is that you have to identify those possible triplet which can form a triangle where each element corresponds to the length of the triangle. For example, if you have taken 2, 3, 4, this does forms a triangle. Yes, forms a triangle. Such that we have to identify all the possible triplet combination that could form the sides of a triangle, and we have to return the count of such possible triplets. And how can we do that? So mathematically, if a triangle has sides A, B and C, then to be eligible for a triangle, A plus B should be greater than C. This has to get satisfied. The sum of the length of the two sides should be greater than length of the other side. That's what we are trying to identify. So how can we do that? So one of the approach we can do is that first, whatever be the list given, sort it. So once it is sorted, then what is going to happen is that that would become in an ascending order or an increasing fashion. So the elements at the end would be higher and elements at the initial points will be lower values. And we can use pointer techniques to identify such triplets. For that, what we have to do is that we can fix a pointer, let it be k, at the end of this particular array, and we can initialize another pointer I at the beginning and another pointer just below the k pointer, let it be j, and we can check whether this nums of I plus nums of j is greater than nums of k. If this is the case, yes, we do have identified one of the possible triplet. In that case, it's always guaranteed that since it is sorted, it is always guaranteed that nums of I plus 1 plus nums of j would be always going to be greater than nums of k, subjected to the first condition is already got satisfied. Like that, it can go up to nums of j minus 1 plus nums of j would be always greater than nums of k. So what we can do, whenever we have identified such a condition, then we don't have to individually vary any pointer. We can just increase the count by j minus I. That we can do. Once this is done, then we can decide to change the pointer of j to the next location. And also, if we have not encountered such condition, if we have not counted such condition, then we should check manually whether this is correct or this is correct or this is correct. In that case, we should update I. And this is done for a fixed k at the end point. Once this is done, we have to again change the k, and again j should be initialized at just one pointer below k, and I should begin from here. Like that, we can efficiently count the possible triplet which can form the valid triangle. Let's try to understand in a much more better fashion when we try to code it. Let's try to code it. So this is the class definition, class solution. This is the method inside the class, triangle number. And what are the arguments? Arguments is nothing but given an integer list. And it is wanted us to return the number of possible triangles which can form from any sort of combination of triplets. So that's another integer. Now let's start. First we need to sort. So before sorting, let me gather few of the information which I can get from this given integer list. So I'm going to get the length of the nums. Then now let's sort. Nums dot sort. Yeah, this is sorted. And we need a counter to count the possible triangles which can form. Now as we said, we are going to fix one k at the very end index of the nums, and that is going to vary once this connections checking between I and j, as we discussed. So for that we are going to fix k. For that I am going to use a for loop for k in range of n minus 1. I am going to start from the last index and I will go up to the 0th index. So for that it's like 1, -1. This we can check. So what happened from here onwards is that we are going to fix I equal to 0 and j equal to, we can write it in a single fashion, I comma j, where I equal to 0 and j is nothing but k minus 1, the one pointer just below the k. And while I less than j, here we are going to check that condition. If nums of I plus nums of j, the condition to become a triangle, that is nums of k greater than nums of k. In this case, as I said, we don't have to count each and every for I. We can just add the counter, count plus equal to j minus I. So that will count all the things, and we just need to reduce the pointer or change the j pointer 1 point below. If this does not happen, then we need to manually have checked it by varying the I. So else I plus equal to 1. So this is it. This will count all the possible triplet which can form a triangle. At the end we just need to return the count. So what is the time complexity here? So as you can see that there is a sorting happening. Sorting has a time complexity of n log n. Another thing, there is a iteration of k. Then inside this iteration there is another iteration like I less than j. So these two back-to-back iteration will have a time complexity of n square. So the total time complexity would be order of n log n plus order of n square. Like if you try to plot it in a time complexity graph, this n square is going to dominate. So in a simpler sense, we can just write the time complexity is order of n square. Space complexity, since we are not utilizing any extra space, that would be order of 1. So this is all about this particular problem. I hope you understand. So thank you for listening.